Hello, my name is David Peruskevich. I'm with the Behler-Young company. Today we're going to talk about the Allen Bradley frequency drives that are being used on the larger Bryant rooftop units for the two-speed blower control. They are using one of two drives. They're both Allen Bradley. The ACS 320, that's this little guy here, and the ACH 550, that's this bigger one. Now, both of them have lights on them, like you see here. We have a green light, which is power, and the red fault light. Now, if the green light is on solid, we're good. If the green light is blinking, we have a fault. If the red light, the fault light, is on or blinking, we have a fault. On either drive, if we have a fault, we need to get the keypad, plug the keypad into the drive, recover the fault code, and determine what our issue is. Over voltage, over amperage, there's various different things. What we're going to focus on today is the hardware portion of this. So we have the drives, and then we also have our relay board. Now, all the rooftops are going to have this as well. There's 4 relays here, which are going to control low or high speed to the blower. So if I were to look at this wiring diagram here, we can simply see there's my 4 relays. So on a call for W1, it energizes K1. If I look through here, 24 volts DC is going to come down here when this is closed, K1. I'm going to come through here, I'm going to energize a high speed setting. Y2, K2. So if I follow K2 across, we're going to see K2 is going to close. We're also going to go to high speed. G, your circulation fan, is K4. So if I follow G across, you're going to see this K4 is going to close here, and we're going to go low speed. So it's basically that. The G, or circulation speed, is low speed. W1 or W2 is high speed, with heating is high speed. Y1, or low speed cooling, is low speed, and then Y2 is high speed. So this is the relay board. There's my 4 relays. It's pretty straightforward. So now, if we take a look at how they're wired to the unit, you'll see there's only a few wires here. So if I were to look at the harness, it goes from the relay board to the drive. This gets plugged in here, and you can see I have 3 wires. I have the blue wires, which is just a jumper. So let's take a look at this for a minute. We're going to look at the ACH 550, the larger one. And we have our 3 pink wires on terminal 10. And here's my 3 pink wires. And you can see from terminal 10 it jumps to 2 other terminals, but the pink wires are all the pink wires. Then we have the ground, which goes to DC common. That's the blue, so that's these blues here. And then we have the yellow, which goes to DI2. Yellow is low speed, and the white, which goes to DI3. Yellow and white. So if you look down in the ACS 320, it's a little bit different, but it's virtually the same thing. So what we have going on is 24 volts coming from the drive right here, comes to the relay board. Now, if the relay closes and sends the 24 volts back down yellow, it's going to be low speed. If it sends it back down white, it's going to be high speed. So we would simply troubleshoot this with a meter. So if I have a call for cooling, meaning my thermostat's calling for fan, my heating has timed out, called for blower, or my cooling's on, so I have a signal going to this board, then I should have one of these relays closed. Now I can check that with my meter. I'm going to go to my meter, I'm going to put it on DC voltage. Now you want to use needle probes. That's these little guys here, these tiny little probes. We start using these big honker probes that come with your meter, and you start cramming them in here, we're going to do some damage. So get your needle probes. So now pink is 24 volt DC coming from the drive. Again, yellow is going back to the drive for low speed, white is going back to the drive for high speed. So it's an open switch. So if I go from pink to yellow, I have 24 volts. That means that the relay between pink and yellow is open, right? So now I go pink to white, I have 24 volts DC. So that means the relay from pink to white are open. So what that's telling me is none of these 4 relays are closed. So this board is not calling for this drive to be energized in the blower. So again, if we go back to here, so we just went pink to yellow. If there's a closure there, that blower should be on. Pink to white, if there's a closure there, the blower should be on high speed. Well, in this case, we don't have anything. Now, I could also go from ground to yellow to see if I have a call, or ground to white to see if I have a call. So now, let's go to the drive. If I look here, you can see there's my 3 pinks, my yellow, white, and blue, coming into the frequency drive right here. So I can also test from right there. So if I go from pink to yellow, I have 24 volts. Go from pink to white, I have 24 volts. Now, if I want to, I could also go from the blue, which is the ground, to white or to yellow. And of course, if I have no 24 volts there, we're not calling. If I have 24 volts, then we are calling. Okay, so that's how I check for a signal. So, do I have a relay closure from the relay board when it's being called for by the unit? If not, the relay board is bad. Now I want to point out these 2 jumpers here. You can see our factory cut. If we replace this board, we want to make sure we cut those jumpers, because if we don't, the blower will never shut off. All right, so I just checked here. And let's say I have between pink and white, I have no voltage. So from ground to white, I have 24 volt DC. So that means I should be running my high-speed blower. Okay, so next, we're going to look at the outputs right here. So here's first my AC coming in, and you can see it's plainly marked main, AC coming out, and it says motor. So now what I'm going to do is let's check for AC volts coming in first. So we're going to put it back to AC, and I'm going to go from L1 to L2. I got line voltage. L1 to L3, L1 or L2, L3 to see if I have line voltage coming in. Then I can go to my outputs here. Same thing. I'm going to go, in this case, I'm going to say, okay, L1 to L2, I have nothing. L1, L3, I have nothing. L2, L3, I have nothing. So if I had a relay closure, meaning I had an input here, I have line voltage coming in, I have no line voltage coming out, the drive is the problem. All right. If I have line voltage coming out, now it might not be full 230 volts. Coming out of the drive, the voltage could be different, but if I have the same voltage on all 3 legs, on the output, and the motor's not running, now we're going to look at the motor. So we're going to go ohm the motor out, wait for the overload, whatever, we're going to check the motor side. Okay, now in the event that this drive fails, the new drive has to be programmed. Okay, so the new drive is going to come with the keypad. We're going to have to go into the book, find out what the original settings are, and we're going to have to program this drive to the new motor, or the unit. All right, out of the box, it's not going to be correct because it's, again, there's 2 drives we use. It's just programmed differently, so we're going to have to program it. Okay. However, to bypass this drive, so you get to your job, we troubleshoot this, right? Okay, we got a closure between pink and white, so I have closure between pink and white, and my drive should be calling. I have 230 coming in, or 460, whatever the case may be. I have power, no power going to the motor. We've determined the drive is bad. So now we can bypass this drive. So if I look at the wiring, you can see right here, this is the wiring that would be going to the motor. And you can see there's factory spade connectors on it. Now, if I take the wiring going to the control box, or from the control box, there's factory spade connectors. So I can take the power from the control box, unplug it from this. I can take the motor on the other end, unplug it from this, and just plug them together and eliminate or bypass the drive. Now to do this, definitely shut the power off to the unit first. And secondly, once you power it back up, that blower is going to run full speed. No contact, or it's going to run full time, but the unit will work until you get back to the drive. Now one of the thing here is how this works here, is the smaller units, the 580J 07 through 14, there's a fuse box that's in line with the drive. So I want to make sure I take this fuse box out as well. So you can see there's spade connectors here. So for my control box, I'm going to unplug here. I'm going to unplug from the motor, and I'm going to plug those directly in. So I have to get those fuses out of this circuit. Why? Because those fuses are not large enough to handle locked rotor amps of this motor starting without the drive on it. So you're going to blow those fuses, and they're not cheap fuses. So if you have the inline fuses, bypass those as well. Get the new drive, plug the new drive in, and reprogram the drive. If the old drive is still if it's not fried to where we can power it up like this, so your drive will still light up, I can actually go into the old drive and I can download the program into my keypad and then upload it into the new drive when I get it, so I don't have to mess with the programming. But the programming is pretty simple, pretty straightforward. As a matter of fact, the new units, it actually lists the programming on a tag on the front of the unit. So anyways, that's pretty much it. I can check, do I have a closure between pink, white, or yellow here? There's where my call is for my relays. Am I getting the signal to here? Between pink, white, and yellow, again, pink is 24 volts coming from this, yellow and white are coming back from here to here. So if I have a closure, from pink to yellow, I'm not gonna have anything. If I have power, it's open. Okay, yellow is low speed, pink, white is high speed. So that's pretty straightforward. On the ACS 320, it's very similar, but there's my terminals here. Now I have my little jumper wires on here just for testing, but it's the same thing. I'd have pink for 24 volts. My yellow would be low speed, white would be high speed, so I can check for right here if I have that call. And here's my incoming power down here. There's my line voltage coming in, my line voltage going out. So I can check if I have power coming in, I can check if I have voltage going to the motor. Okay, so that's pretty much it. My relay board and the hardware of the VFD itself. That's pretty much it. So if you have to change a drive or test the drive, it's pretty simple. You can bypass it. Once you get the new drive programmed and installed, of course you tie it all back in and get it running again. That's my tip. I'm Dave Perskevich with the Behler-Young Company. If you have any other questions, feel free to get a hold of one of the three of us, and we can help you out. Thank you, and have a great day.